Hello everybody. This is my second video on robo theory, and today we're going to be talking about what defines a robot. So in this video, I'll be explaining what criteria that I think defines a term we often use in robotics, robot. This is really important, especially when starting robotics. This is one of the key concepts that everybody should learn because the word robot is very hard to use in robotics. Like sometimes people say this machine is a robot, but it's not. So let's talk about what a robot actually is in this video. So a robot versus a machine. So the first thing we must answer is the difference between a robot and a machine. The basic concept is that all robots are machines, but not all machines are robots. Keep in mind, a machine can meet some or more of these benchmarks. So a machine could have a power source, which is one of the benchmarks, but it might not have a program behind it. It might just be operated just free-handedly. So a machine can meet some or more of these benchmarks, but a robot must meet all of them or more. So a machine can't meet all of these requirements, but a robot must meet all of them or even more requirements past my criteria. So also keep in mind, of course, this is always debatable in the real world because there are a lot of debates on what actually defines a robot, what a robot actually is, and just keep in mind this is just based off my opinion. But I took it based off other people's opinions on their criteria, and I put it all together to take my opinion. So the benchmarks. There are a total of 7 benchmarks that I have. Monitoring the environment, must be programmable, interact with the environment, needs a power source, a language with understandable instructions, must be non-living, and interact with the environment are all 7. So let's start. Monitoring the environment. So like what the robot senses when just like moving around. For example, measurements like temperature, distance, and gyro angle are all important. So you need to be able to monitor the environment. And over here, I've shown on the left some sensors because sensors are the key way to monitoring the environment, just like an ultrasonic sensor or like, for example, a heartbeat sensor, which detects your heartbeat, like how fast it's going. Smoke sensor, we have a lot of those, smoke detectors, everybody has those. And basically it detects if there's a certain amount of smoke, then it'll start sending out an alarm to the firefighters. So the robot must be able to recognize this through sensors or through changes in code. This attribute is important for a robot, and it's really important actually, especially considering that other benchmarks are actually based off this one. So next is must be programmable. The actions the robot must perform or act upon must be programmable. It cannot be a task that cannot compile with the robot's build. For example, if you want to build, if you write a program for a robot to go to Mars, but you just have let's just say, an iRoomba, and you want to program it to go to Mars. I mean, an iRoomba is only dedicated to cleaning. It doesn't have the rocket, the tools, everything it needs to go to Mars. So it must be programmable, and yeah, it cannot be a task that can't compile with the robot's build. Basically, the code must be built based off of the operations that the robot must perform and can perform. Interacting with the environment. Okay, so over here I have shown the VexIQ challenge. I forgot which challenge, but basically the robot is picking up 3 blocks and stacking it on top of the blue block. So this ties back to the first benchmark, monitoring the environment. And while monitoring, the robot must change or interact with the environment. That's one of the key phrases in robotics. The robot must be able to do something because that's the whole point. Robot is supposed to limit effort, and just doing something will actually limit effort. So the VexIQ robot is pulling up the blocks and putting them down. Now, in reality, we could easily pick up these 3 blocks and put them there, but if we take it to another level, for example, picking up a bunch of like heavy 1-ton blocks, like 3 of those, and stacking them onto another ton block, then imagine how heavy that would be. That's why we need robots. So a robot must be able to make an impact or change to its environment, whether it's a challenge in space or a task underwater. The robot must be able to do something. Power source. A robot requires a power source to be a robot. This is one of the key places that, it kind of ties with machines and robots, but it also excludes other things that people call robots. So a power source will help the robot carry out its assigned task, which is important, otherwise it wouldn't be able to do anything in the first place. So if you just have a robot that you just have to push, it's like a Rube Goldberg machine, for example. It might have a power source as the beginning, but really has to be more of a power source that will keep the machine keep on going. Like a Rube Goldberg machine, it does have a power source. It is a machine, in fact, but it's only a one-way through. There's no redoing. It doesn't go back and forth. And the only exception to this benchmark is actually a SoftBug, which is an online robot that scans around the web. So this is really an exception because a SoftBug is kind of like a robot, but it doesn't really have a power source, but I'll keep an exception for it. Otherwise, some power sources can be batteries, solar energy, and much, much more. A robot language. Robots must be able to understand the language like we all do. There must be a translator or a way to tell the robot what to do. So we have programming languages since human languages are way too complex for robots to understand. A robot must be able to understand the language. Another viewpoint is that a robot doesn't have to be completely changed when given a new code. Instead, a robot can receive new instructions from the program and achieve a different task. So what this means is that, for example, in an assembly, if a machine is picking up certain items and is stacking them on top of each other. Now, if you want to change it so that it stacks it into a different way, you can't change the code because it's based off what the robot's ability to do. So if you want the machine to stack it sideways instead, what you're going to have to do is change the whole robot because it doesn't have the ability to change how it's stacked. So this is probably one of the most important criteria. And now 3 operations, the 3 basic robot operations. As reviewed in my first video, there are 2 basic types of robot operations, but these robot operations are also key into deciding whether a machine is just a machine or actually a robot. A robot must be required to be either teleoperated, autonomous, or hybrid, which is basically a mix of both, allowing code and human controllers to work together. Machines, most of the time, cannot be human operated. Non-living. Well, this is more of an overall excluding living things. So basically, recently, scientists created a robot that contained a frog brain inside to see its capabilities. The robot, quote unquote, was successful. However, the question I had was if it was actually a robot. Since it had a living brain, I consider it not to be one because the last benchmark that I have is that a robot must be non-living. This is important because a living thing cannot decipher code, be controlled by a human, and have a power source. Indirectly, of course, we might have a power source like ourselves or organs, or have a pet controlled by us, but a robot must complete a simple task with no effort, which no organism can actually do. So now let's compare 2 different machines, because remember, a robot can be a machine, but a machine cannot be a robot. So let's compare 2 different machines and see which one's a robot and which one's not. So iRoomba and a sewing machine. So an iRoomba can sense the environment around it for cleaning, but a sewing machine does not sense when a different material is under it. If there's fabric under it, then it'll just keep on sewing because it doesn't recognize the material. The iRoomba is programmable through its app. And programmable is overall detecting not only buttons, but basically changing through the code. The sewing machine is not programmable. Well, I guess you could consider it programmable, but let's just say for now it's not programmable since you can't actually program the sewing machine in a completely different way. At least for the iRoomba, you can change where it goes. So interacts with the environment by bumping into walls and turning away is what the iRoomba does, while the sewing machine does not interact with the environment. This ties back to the first one. So if you miss the first one and somehow get the third one, it really does not match up. So you have to be able to understand what's the environment, like operate with the environment, and also like operate in the environment, like change something. So the sewing machine does not interact with the environment. They both have a power source because the iRoomba has a charger and the sewing machine is plugged into an outlet as a power source. They both are programmed with a source unknown, but iRoomba is probably Arduino. I have to check up on sewing machine. iRoomba is autonomous, but it might have a mode which puts human in control. And the sewing machine is technically teleoperated because you're controlling it, the robot, but I mean, it doesn't really tie back to what I put in the previous video. So let's just keep it as teleoperated. And now the iRoomba is not alive and the sewing machine is not alive. So let's see. So iRoomba is a robot and sewing machine is not a robot because the iRoomba met all requirements. The sewing machine is a machine, but it doesn't meet all the requirements that I have. So thank you guys for watching this video, and remember to follow me on Instagram. Remember to subscribe and like, and if you have any questions, add them in the comments. Thank you.